In this video, you'll learn all about installing a Champion manual transfer switch. Homeowner Brad Need will be working alongside licensed electrician Mark Addison as they put in the 30 amp model. Procedures for the 50 amp model are the same, and this video is designed to work alongside the installation manual, so be sure you've read it right through before you begin work. Begin by determining which essential circuits you'd like to be able to power with your generator during an outage. Here Brad has labeled all existing circuits, but marked those essential circuits with a check mark. Start work by switching off the main breaker, then removing the access panel so you can get at the circuit breakers. Here Brad is explaining to Mark which circuits he wants powered during an outage, and Mark is labeling individual cables so he knows which ones to reroute into the manual transfer switch. Here Mark's opening up the transfer switch case so he can deal with some of the circuit breakers and things inside. The cover of the box disconnects from the main box. That's one of the first things you should do because you don't want that cover dangling around during the installation. Depending on the details of the electrical code where you live, you may or may not be allowed to make generator connections within the main electrical panel. Where this installation is happening, that is not permitted, so Mark is removing the wires that came with the switch. In this situation, there's enough cable length leading into the main panel that those cables can simply be disconnected and rerouted into the manual transfer switch. If your cables aren't long enough, you may need to install a separate junction box within which the connections can occur. Many jurisdictions require an arc fault circuit interrupter breaker for certain circuits, and that's the case here. The manual transfer switch does not come with arc fault breakers, so Mark is removing that type from the main panel, and he will be putting them into the manual transfer switch. There's usually a lot of wire and cable involved in an installation like this, so it's important that you label everything carefully so you get the correct circuits directed for generator powering. Here Mark is removing the arc fault protected circuits from the existing panel and moving them to the manual transfer switch panel. Because the transferred circuits are arc fault protected per local code, Mark is required to replace the manual transfer switch breakers with AFCI breakers. Always be sure that any breaker you install is rated for the panel it's going into. With the regular breakers removed from the transfer switch panel, replace them into the main panel so that the holes in the cover are filled when it goes back on. Here Mark is removing the cable staples, holding the cables in place, the ones that will be redirected into the manual transfer switch. Now it's time to install the transfer switch onto the wall. Make it close enough to the main panel that you can get the cables in if you've got that kind of length, and install screws in all the holes for mounting the switch. If Mark had been making use of the existing wires that came with the switch, he wouldn't need to remove the knockouts, but since he's directing individual cables into the switch box, he needs to make openings for those and install some cable clamps. Here Mark's using a step bit for drilling additional cable access holes into the side of the switch panel. With all the cables routed into the switch panel, it's time to install breakers in the appropriate places. And of course they need to match the power and safety requirements of the circuits that they're protecting. Continue work and complete all of the connections happening within the switch panel, all the connections related to circuits. So that would be ground, neutral, hot wires, and any additional wiring coming off the arc fault breakers. Finish up with the circuit cabling by reinstalling some staples to secure everything in a safe and neat way. Now it's time to start working with some heavier cable. Mark is opening up some knockouts here to allow a cable from the main panel to enter the transfer switch, and this provides electricity to your essential circuits when the grid is up. Now, since we're dealing with a 30 amp transfer switch, we're using number 10 cable and a 30 amp breaker in the main panel. If you were installing the 50 amp model, you need heavier cable and an appropriate 50 amp breaker in the main panel. Regardless of the size of transfer switch you're installing, you'll need to use double pole breakers. So these provide 2 phases of 120 volts for a total of 240 volts when you need it for something like a stove or a dryer. After securing the heavy cable with staples, Mark's making the appropriate connections within the transfer switch panel. So that would be the ground wire here. The white neutral is going to go to the N lug, and the 2 hot wires, in this case the black and red, will go to the L2 and L1 lugs. Be sure to tighten these to the appropriate torque. The other end of the heavy cable gets connected to that double pole breaker I was telling you about. In this case it's 30 amp. The black and the red go to the terminals on the breaker. The white goes to the neutral bus, and the bare wire goes to the ground bus. Now it's time to switch gears a bit. Brad's boring some holes through framing members to run the other leg of heavy cable. This will connect the transfer switch panel to the outdoor inlet that the generator will be connected to during an outage.
This is just a screw to mark the location.
One great way to know where you need to drill a hole for this outdoor inlet is by driving a deck screw from the inside out to mark the spot. Here Mark is running that heavy cable from the outside in through the exterior hole that's been drilled and the holes in the wall studs. Now's the time to install the outlet box with the appropriate cable clamp to secure that heavy cable. Screw it to the wall. Use a small level to make sure you've got it oriented correctly. Make the appropriate connections within the inlet box. So that would be the green ground wire that grounds the whole box. That goes to the ground lug. And then the black, red, and white wires go to the appropriate connections on the actual inlet connector itself. Finish up with this part of the installation by securing the cover of the inlet box, and then you can move on inside to complete the connections at the transfer switch panel. Finish up the inlet side wiring in a similar way as you did when you were working with the other heavy cable. So the ground wire goes to the ground lug on the panel. The white wire goes to the neutral lug, marked N here, and the black and the red go to the L1 and L2 lugs. Notice how these connections are made in the front set of lugs, whereas before your heavy cable connections were made to the back set of lugs.
13.
Double check everything and update any of the labels that need to be changed on your panel. And then it's time to reinstall the cover on the transfer switch. So you make that wiring connection, replace the screws, and tighten them down. You should also mark the transfer switch panel with the appropriate labels for the circuits that it powers. No transfer switch installation would be complete without testing. So begin by firing up the generator, then make the connection with the cable to the generator itself, and then the inlet port. And when these things are connected, run a test, switch the main breaker off on your panel, and then hit the generator activation button to make sure the generator power really does power all of the circuits that you had in mind. Your installation's complete now, and you're all set to deliver power to essential circuits the next time there's an outage.